Let's do some examples. So let's use the x-axis intercepts to sketch the graph of these things. Okay, very first thing that I would like to do is find out what my y-intercept is. So my y-intercept is when x is equal to 0, so I have two lots of 0 plus 3, 0 minus 1, and then 0 minus 3. Put all that in the calculator and end up with 2 times by 3 times by negative 1 times by negative 3, and that's going to give me 18. So I know I'm cutting my y-axis at 18. Next thing I want to look at are my x-intercepts, so that's looking at all of these. So I know from my first one, here my x plus 3, I'm going to have something at minus 3. I also have one at positive 1, and I also have something at a positive 3. So they're my 3 or my 4 little bits that I know I'm going to go through. If I look at my front terms, my a here, 2 is bigger than 0, so I know it's going to go in this direction. So let's draw that by putting all these things together. So I know I'm up here, going up, down through there, down underneath, and then up through there like so. And this is roughly what our cubic would look like. Let's do a similar thing for part B. So find our y-intercept. So that's going to be negative lots of 0, 0 minus 2 squared times by 2 lots of 0. Having a field day with the technology. Plus 1. Put all of that into my calculator, end up with negative lots of 4 times by 1. And that's going to give me negative 4. So now I'm cutting down my x-axis, my y-axis at negative 4. Okay. Next thing I want to look at are where our x-intercepts. So if I create a scale here where 2 of these things is 1, and another 2 is 2, and I'm just drawing my scale in. So if I'm now looking here, if I look at my 2x plus 1, and I want to set that equal to 0 to find my x-intercepts, I can minus 1 from both sides, and I end up with minus 1 on 2. So I know I'm going to have one axis hitting at that point where I just put the dot. And I also have, let's pick a different color so that we can actually see it past everything. But one spot there, and my other one is at 2. Now what can you tell me about this 2 there is that it is just touching. Okay, so I know I'm not going to cut through, it's going to be just touching. Whether it's on the top or the bottom, it remains to be seen. But we do notice that we have a negative out the front, which means it's going to be looking in this direction. So let's draw that in now. Let's draw we know it cuts in like that, and then it's going to go up, and it's just going to touch at 2, but not go through it, and then we go down like that. And that is how you would draw your cubic. So here is the nicer drawn version of it. Depending on the scale, will depend what it looks like, but just be careful. And there's the nicer, again, versions here that you can pause on to have a read. So if we wanted to find the equation of the cubic with these graphs, let's have a go at doing that. The very first thing we want to do is we want to actually write down our form. So I know I have cutting at 3 spots. So it's going to take form a x plus 1, x minus 2, and x minus 4. And remember, I do have that a still out there. And just like we did with quadratics, we've got x is equal to 0, y is equal to, in this case, -8. Substitute that all in. I get -8 is equal to a times by 0 plus 1, 0 minus 2, 0 minus 4. A of -1 times by -2 is -2 times by -4. It's going to be +8. So I'm going to end up with a is equal to -1. So my equation for this is just going to be negative x plus 1, x minus 2, that's our equation. And that matches up. We know that with the negative it should be in this form, and that matches up with what our picture looks like. Now, part B is a little bit more tricky. To start off with, we do the same thing. We have y is equal to a. I know I have it cutting at -3, so I have an x plus a 3. And then I have this here where I have a 2 on 3, so I could do x minus 2 on 3. And I'm going to square that because it's just touching. It doesn't go through, it's just touching. Okay. So one thing I want to note here though is we have it at the moment being x minus 2 on 3. Another way I could write x minus 2 on 3 if I just want to be able to find my zeros is I could also write 3x minus 2. Right, if I tried to set that equal to 0, I'd get the exact same zeros. So we can use this form if we wanted to, right, instead of this bit here. Right? I personally prefer this way without fractions. Makes life easier. The only difference is, depending on what way you use, you get a different a value. Right? Because a, what it does is it's what you multiply everything you get in order to get to the end. You just pick one way and go with it. I personally prefer, like I said, this one, so I'm going to use that from now on for the rest of this question. And have a go at doing this good old-fashioned way using your other form if you would like. So we've got 3x minus 2 squared. And then we just sub in when x is equal to 0, y is equal to 6, 6 is equal to a lots of 0 plus 3, and then I've got 3 times by 0 minus 2 squared. This ends up being, so I've got a times by 3, and then I've got 3 times by 0 is 0, minus 2 is minus 2, square that, and that's going to be 4. So then a is going to be equal to, and then I have 6 divided by 3 times by 4, which is 12, and that is just a half. So y is equal to half lot of x plus 3, 3x minus 2 squared. Alright, now if you were to have picked this form, you'll have a slightly different value of a. You will not get marked down if you use that form, which is going to look different because if I was to experiment the set all out using FOIL, which you can do, don't necessarily recommend it, it takes a long time. You can expand it all out and you'd end up with the same thing, even if you value of a at the front is different. So I recommend you, if you're feeling a little bit unsure about that, do both ways, expand them all out, use the FOIL, expanding the brackets, and see how you go and whether they match up. They should. You're just going to get different a values depending on what form you're using in our end equation. So if you want to have a read through, I've got it there on the right. Alright, now very last thing in This is looking at it. It kind of looks a bit like turning point form, but not quite. So I just want to go back and remind everyone. So I'm just going to escape out of this because I think my PowerPoint needs a moment to catch up with my pen. Often does this. So I do want to go back to our very first topic. Right, our very first topic that we did, functions and graphs, is going to be really important going forward in this topic. So if I have f of x is equal to x cubed, which is our first one here, our original graph is going to look something like this. And that's roughly what our cubic looks like, our stock standard one. Now if I had f of, and this is a question to ask yourself, if I had x minus 2 in here, if you can remember what the first topic said what would happen here, is it's going to end up being f of x shift to the right 2. Right, and in much the same way, if I've got f of x, and then I've got plus 3 on the outside, what this means is f is getting shifted up 3. Alright, so I'm mentioning all this again because that's really what's happening here. Alright, this is f of x minus 3 plus 1. Alright, so it's our original function, substituting x minus 3 into my x to the power of 3 part, and then I'm going up 1. So what we really want to do here is we want, I'm going to use a different color, is we want to go across 3. So I go x minus 3 cubed, right, that is shifted 3 to the right. So where I originally hit my axis at 0, I'm now going to hit my axis at 3 instead, so it's going to look something like that. And so everything's just been moved to the 3. Whether my scale shows it or not, everything just moves 3 across. So then if I'm going to, let's get a different color again. Now if I'm going to add a 1 to the end of this, I'm now shifting 1 up from my last picture. Okay, so that's this new one. So where I have from there, everything is moving up 1. So now everything's going to go up like this. Everything is just 1 higher than before. Okay, it's all just been shifted up 1. So use your one that started, and then from there, see how much you're shifting. This is to the right 3 and up 1. But it's all just using the stuff that we learned in functions and graphs. And that's all for me. Hopefully that answers any questions. If you have any other questions, email me and I can get back to you on that. Thanks for listening.